most students tend to wind up using stuff that involves categorical variables, such as gender, such as echnicity, and so on and so forth, to examine stuff, because that's the bulk of the information that's in here, and that's usually things like chi-square, for instance, where you're comparing for males and females, how many of each group got a flu shot, how many didn't get a flu shot, and so on, or by ethnicity. Now that works great. Chi-square, any kind of we work with chi-square for any kind of contingency table. 2 rows by 5 columns, 5 columns by 3 rows. Any of them will be okay because you can create a table of estimated values, what you would expect to happen if there's no influence on that, by ethnicity or by gender and so on. But the problem is that that's fine for chi-square, but you can't do odds ratios. Odds ratios will only work in SPSS for 2 by 2 tables, where you compare one group to another group to get a risk ratio or an odds ratio. So I'm gonna take a look at this data. You can see there's tons of stuff here, and one of the problems, and Levi has extracted a certain amount of it. I'm going to minimize that so I can go back to the simplified one. He's um, uh, extracted a few interesting categories here, a few interesting variables. The borough the person lives in, some sort of demographic variable. We'll get a look at that. Something that looks like new race, neighbor, poverty group. See, they kind of it's when they give you these variable names, a lot of them are kind of nebulous, kind of hard to figure out what they are. Well, flu vaccine shot, ones and twos, we can probably deduce that that's probably they got it or they didn't get it. And sex, they can ones and twos. You can probably figure out that that's males and females. Now in SPSS, you can go up to the view selection, and you can say view by value labels or don't view by value labels. That's in other words what these numbers mean. So you can toggle that on and off, and you can see in this case they don't change, right? So what's
Right.
happened here is that SPSS only knows these as ones and twos. It doesn't know actually what the value means. So I'm going to change my view to the variable view. I can do that by either saying, going up here to view and say view variables or view data.
Okay.
Okay, or I can do it down at the bottom here on a Mac. A little different on a PC, possibly. It might be in slightly different spots. But
Yeah, I've just been toggling from the bottom menu,
yeah,
like you just
okay.
said.
So now we're in the variable view, and the only thing that's changed here is that each column here, each variable, is now represented by a row. So when we were looking at gender, that's
Uh-huh.
the eighth column. So it's the eighth row here. And if I expand these a little bit, you can actually start to see what some of this stuff is saying.
Hmm.
I'm gonna, oops. It's not as cooperative as Excel is in terms of expanding individual group. Oh, there we go. I had a row completely selected there. Okay, so the eighth one is sex, male or female. Pretty obvious, right?
Yeah.
And I look over here and I see, okay, column. Let's see, values, numeric, meaning there's a number displayed there. It's one. The width is one, meaning it only needs one digit. And if I move over a little bit here, let me move this out of my way. If I move over here on the eighth column, I see that it aligns to the right. It's a nominal variable, and
Hmm.
it's an input that someone put into this. In other words, we're applying values to it. Okay, so now the things that are not filled in right now are things like values, missing, columns, and so on and so forth. Okay, so the important thing here is the values. See, nothing's filled in right now for values. So I have to go to gender or sex. As a matter of fact, one of the things you can do is the variable name is sex. The variable label is sex, male and female. Now, that's not a bad variable name. You could have that show up on a chart and people would understand what it means, but people might not understand what for instance, this variable name means. So it's nice to have a way to tell Excel, well, display that variable in a more descriptive form when I do a table or a chart. So you can actually go into the label here and change that to whatever you want. For instance, it's really what it stands for is neighborhood poverty based on percent, zip code, and it's determined by the zip code of the resident. Okay, below 10%. That's a little bit too descriptive, right? You don't want that one on a chart. Okay, so you
Right.
might want to abbreviate that somehow or other into a more suitable form. Like maybe we'll just call it neighborhood poverty, right? So from now on, that's how it's going to be displayed. I'm not sure that that's the best way to do it, but for our purposes, let's change it to that. So now we have to tell it gender. What is a one and what is a two? Well, we could guess at it, but it's better if we actually know. Okay, so I'm going to go. There's another file that's on Blackboard. Is the code book for SPSS. So I'm going to double click on that. It's just a PDF file, and it literally represents every variable. And this has been a trimmed down table, but if you go through here, this probably starts at the first column and then moves through it. So you can actually go through here, and let me see if I can. I'm going to do a search. You can't find this variable. Okay, it shows up in a few spots. Okay, sex. This is the variable sex. I managed to find it. And the question is, you can see what the question was, how it was phrased, and one represents male and two represents female. So I know that now. So I can go into my SPSS file and I can click on the value label for gender or sex and click here and say, okay, one represents male, two represents female. And as soon as I do that, SPSS is not going to understand what that number means. Now, you might want to watch this. If I click OK, it gives me a warning because it hasn't
Yeah.
actually added that last value. I have to actually click add, not just OK, to get it
Oh,
this value. So I'll say OK. So now it understands what gender is. Now, as far as the flu shot is concerned, we're going to need, since we're working with contingency tables, odds ratio, we're going to have to tell it who got a flu shot and who didn't. And that should be in one of these variables. So it has flu vaccine shot. Now again, I got to go back to the table and search for flu vaccine. I think there might have been a dash there. I'm not sure. I'm just going to do, here it is,
you.
flu vaccine shot. One means yes, two means no, and these others, dot D and dot R, represent don't know or refuse. Well,
Okay.
we can include those or we can exclude those, either one of them, dot D or dot R. In fact, SPSS will actually work with these, but one is yes, two is no. Okay, and I'm going to go in here and I'm going to tell it. Let's see, here we are. Okay, I'm going to tell it that flu vaccine, receive flu vaccine. I may just want to trim it to just that. Okay, so it actually says receive flu vaccine slash or a nasal spray or whatever. Okay, and I'm going to go into values and tell it now. What do you remember what it was? I forgot already. That they one was yes, I believe, right?
Yes.
Okay, good. Two is no. Okay, and the others were either refused or whatever. They were other factors. I'm going to ignore those. I'm just going to look at ones and twos and say, okay, I'm just going to define ones and twos. And I'm going to see what happens here, just for the hell of it, so that we can see what goes on here. If I go back to the data view now, notice
Mhm.
these are filled in here. That was a one, that was a two, female, and so on and so forth. To go to the variable view, they go up to view and toggle it on and off. It'll turn on and off now. You can see what they are. So now at this stage, I can do some statistics. I'm going to go, since there are two variables, we want to know whether or not sex is associated with whether or not you don't have a flu shot, if there's some association between those two variables. So I'm going to go up to analyze. I'm going to go to, I'm not going to go to compare means because they're just categories. I'm not going to be able to do a mean. That's for numerical variables. I'm going to go to descriptive statistics, crosstabs. And usually I like to put the exposure in the columns and the outcome in the rows. So the exposure here would be something like exposed to a metal or a virus or, or whatever, or is a drug user. Or, in this case, happens to be gender. So I'm going to move sex, male or female, into the columns, and I'm going to move whether or not they got a vaccine, got received the vaccination, into the rows. I'm sorry, I got that backwards, didn't I?
Well, wait, why would you? Okay, yeah, because I was
I got it
thinking there.
backwards.
Yeah.
Receive flu. The sex, male or female, is the exposure, and receive flu shot is the columns. Okay, so now I can choose to do a whole lot of statistics here. Chi-square, risk, meaning odds ratio, and relative risk, and so on and so forth. I can put all sorts of information into the cells, each cell. Right now, I'm just going to leave it checked off, observe, nothing else. And I'm going to click OK. So we'll see what happens. Okay, so the output window should come up. If it doesn't, we can make it pull forward. And here we go. Here's our results. Okay, it said that there were 8,643 cases that it examined. That's 99.4% of the data that was available. 55 cases it listed as missing. Had no, it didn't know whether they got it or not. Well, in fact, they refused it. They refused it, or there was some other designation. For the moment, I'm going to ignore that and just look at the other 99.4% of the cases. Okay.
Okay.
Okay, so what would be, if we wanted to know what percentage of males got the flu shot and what percentage of females to see if there's a difference, you would just take 1596 over 3716 and 2307 over 4927, right? That,
Right.
that that's the number over the total. That's the number over the total females. Makes sense, right?
Definitely. Yes.
Okay, so I'm going to go up to Analyze, and I'm going to get spss to do it for me. I'm going to go back into Analyze, Descriptive Statistics, Crosstabs, except this time when I go into Cells, I'm going to check off percentages by rows. And it's going to give me all those percentages by the rows. Okay, do it again. Output table comes up again. And this time, it gives us all the numbers it gave us before. It sorted the table out for us. But this time, it tells us that 42% of males and 46% of females received the flu shot. So it looks like females were more likely to receive the flu shot than males. This, in fact, is the risk, what we would call risk of or rate, risk or rate of receiving a flu shot for males, risk or rate for females. And if I actually divided one by the other, I would have the relative rate or relative risk. 0.42 divided by 0.46 would give us like 0.8, 0.9 or something like that. And that would tell us that males are 90% as likely to get a flu shot as females. That would be our risk. Well, the problem here is that we don't know whether that difference between these two is really statistically significant. What's the likelihood that we would get that big a difference? Is it something that would happen easily by chance? In other words, if we had, remember, we only sampled 8,000 people out of 8 million.
Hmm.
So if I sample another 8 million, maybe I would have gotten the reverse of that if there's not too big a difference. We certainly wouldn't have expected to get exactly the same rate, even if we're the same rate in the population, just by chance. Okay, so now I need to know whether or not there is an argument to say that there's an association between gender, being male or female, and a difference in the rate of getting a flu shot. So chi-square is ideal for that. It's a 2 by 2 table. I can go up here, analyze, descriptive statistics, crosstabs, and this time I can go into statistics and calculate the chi-square for me. I'm going to click continue and say okay. And this time, again, it produces the same table as before to start
Right.
off with. We didn't uncheck any of that. But this time it gives us a chi-square value. And the chi-square value is 12.8. So now, do you recall what the critical value was for a chi-square table, a 2 by 2 chi-square table?
I
Remember that?
actually don't. I'm sorry. Um,
You happen to remember?
I feel like it's lower than 12.
Yeah, it was like 3.84, right?
Yeah.
Having to do this every semester for 10 years. I happen to remember it. I don't expect you to remember it though, right? But if you go to the table and the degrees of freedom, they're based on the number of rows minus one times the number of columns minus one. So 2 minus 1 times 2 minus 1 is 1. So it's 1 degree of freedom. So this is your chi-square value. This is the probability you would be wrong if you rejected your null hypothesis. In other words, this is the probability you would get this big a chi-square if there was really no association between gender and receive the flu shot. Okay, so it doesn't look like there's much chance of being wrong if we reject the null hypothesis that there's no association. So it does appear that gender influences whether or not you get a flu shot, and here's statistical evidence for it. One of the other
Right.
things I'm sorry, go ahead. You
Oh no, I
stop
was
me.
just following
I
along.
tend to, because I can't see if your face.
Yeah.
I have a tendency in this environment to like talk over you. So just say, stop, Tony. Stop, so I can
Okay.
what you're about to say. The other kind of statistical test that we can do is a odds ratio or relative risk. So
Well,
I'm going to go
actually,
back up here.
I do have a quick question.
Sure.
So if percentage was something other than zero, because it's point zero, so we know that it's uh, we can reject the null hypothesis.
Right.
But is there another test that you would do if it were to say give us a sign that we couldn't reject the null
Well,
hypothesis, or is it just that you
remember,
reject?
remember, we're willing to tolerate up to a 5% chance
Oh,
of being
okay.
wrong if we reject the null hypothesis. That's our alpha. That's our acceptable alpha error. Now, the probability for us is less than 0.001, less than 1/10 of 1%. So we have, if this had come up 0.06, we would have failed to reject the null hypothesis.
Okay, and there's not any further statistical anything, you just reject it and you move on.
No, but you might say to yourself, well, gee, maybe gender doesn't affect it, but maybe now I should take a look at at the age groups, at the relative at different ages. Maybe
Okay.
now I should look at ethnicities. Maybe now some other factor that might influence whether or not the person is likely to get a flu shot.
This really helps with comprehending the null hypothesis in a practical way because it was really hard for me to conceptualize. And I kept having to stare and stare at word problems and rewrite it. But looking at this table is really helpful for understanding the pieces of it. I don't know, it just kind of put it all together for me.
Okay, good. All right, now I'm going to do one more test here. I'm going to actually do an odds ratio or a relative risk. Now, what is the odds ratio going to be? And what's the relative risk going to be? Well, we already know the relative risk is 0.42 divided by 0.46. So it's going to be a number like zero point 0.9 or something like that, right? Now, the odds ratio gets a little bit more complicated. The odds is the yeses divided by the nos, right? 15, whatever that is, right? And
Okay.
the odds for females getting a flu shot are 2307 to 2620. 2307 divided by 2620. Kind of an awkward thing to think about, right? The risk is more intuitive, but in many studies they prefer to use the odds ratio. There's a number of reasons for that that we don't have to worry about right now, but
Okay.
that's the odds, right? So I'm going to go ahead and I'm going to ask it to calculate the risk and the odds for us. I'm going to go to Analyze, Descriptive Statistics, Cross Tabs, and this time I'm going to go into the statistics, and I'm going to say Calculate Risk. I'm going to click OK. Click OK. Okay, so now SPSS at this stage it just does the same thing. It calculated the chi-square value, and it also calculated it with that mysterious continuity correction. Like in other
Mhm.
words, using subtracting a little bit from the calculation that observed minus expected. You subtract a zero point 0.5 from that before you square it, and so on and so forth. That makes it a little bit more conservative. You get a different value. A lot of people like to do that with 2 by 2 tables, particularly. I think for our purposes, you could use either one of them. I would just check with the Pearson's chi-square, and in fact, you can see that there's almost no difference between them anyway. So I wouldn't be worried about that too much at this stage. Okay, so let's look at these odds ratios that we calculated. Well, one of them is the odds ratio, and the other one is the relative risk. Well, the odds ratio is easy. Odds ratio it says right there, 0.855, right? The relative risk is this next one for cohort received the flu equals yes, and it's 0.917. Don't worry about these other two. This one is the inverse of the relative risk. Okay, the percentages. Okay, so it's just one divided by 0.917. So you're just looking at the top two columns, right? So our odds ratio and our relative risk are less than one. That's because males who are a lower percentage happen to be on the top of this column. If males were on the bottom, then it would have been point nine one point. It would have been one point something. Females would have been on top, and you would have divided that number by a smaller number, and it would have come out above one. So really, this just tells us that being a male means that you're less likely to get a vaccination than being a female. This is the odds ratio way of doing it. This is the relative risk way of doing it. So now, if our assumption that there's no association between gender and getting a flu shot is true, you would expect the percentage for males and the percentage for females to be the same, right?
Mm-hmm.
So what would that make your relative risk or odds ratio if the percentages were the same?
One,
Yeah, make it
really.
one, right? So the key here is do we have enough evidence to say with 95% certainty, less than 5% chance of being wrong, our alpha, do we have with 95% certainty, are we able to say that this value, the odds ratio and the relative risk, that those numbers are really not one, are really less than one? And that's what the confidence interval tells us.
Right.
Okay, so we think that the odds ratio and the relative risk of these numbers, but we're 95% sure that they're between 0.78 and 0.93. So what's excluded there in that range? One is not in that range. So we're 95% sure that it's not one, which means we can reject the null hypothesis that the relative risk is one.
Right. Okay.
Okay, or the odds ratio is one, either way. Okay, so does it make sense? So now you can copy this. Now the only problem here is that actually no, we did kind of like reword this a little bit. I might have changed sex to gender, maybe,
Mm-hmm.
maybe not, but we did clean up these variables. So now can I do this with anything else? So you can copy this into your if you just want the raw table, you can copy that in. Here we are over there. You want to copy this, but I think you don't want too many charts. Now, in addition to that, you could also, for instance, go into graphs and you could actually, I like to use legacy dialogues, it's the simplest. You can produce graphs that represent these distributions. Like, for instance, legacy, since these are categorical variables, we're not going to make histograms, we're going to make bar charts. Okay, so I'm going to make a simple bar chart. Okay, and I'm going to tell it, okay, let's just have a bar chart that tells us the gender of the category. Let me think about this category in rows. Let's look at gender in terms of a bar chart. See what we get. Okay, so here's a simple chart that you can look at that'll give you basically a visual view of what the distribution between males and females is in this study. I could do the same thing. I could do the same thing for the number of people that got a flu shot, for the percentage of people that got a flu. Let's see, there's gender. Let's see, refuse. Let's see how many people received the flu shot and how many didn't in this study. Okay, well, more people didn't receive a flu shot than did receive a flu shot. Quick visual represented that. Let's go back again, except let's make this a little bit more complicated.
Mm-hmm.
Legacy dialogues, bar chart. Except this time, okay, I'm going to say simple, and I'm going to tell it. Well, let's see. I want to know the number of people that receive flu shots, but I want to know it by their gender. Excuse me. Let's see if this will do it. Okay, well, this did two separate graphs, right? I want to cluster these. I may want to cluster these two graphs. See, it did for males, did it for females. The
Right.
percentage of males that receive flu shot, percentage of females, not too informative. Let's do it another way. Graphs, legacy, bar charts. So this time I do clustered. Okay, what it's going to do is actually going to put the groups together. So the category is usually a y-axis.
Oh,
So
okay.
let's see. I'm going to put gender in there, I think, and then I'm going to put let's see, that they receive flu shots in
Could
defined
you
clusters.
also
I'm sorry.
uh, could you also put a third in, like insured versus uninsured?
You want to know something? I
Or
don't
is
think
that
I would because think how complicated a bar chart that would be.
yeah, no,
You know,
it's true.
so let's see what we get here. Okay, see if I got it the right direction. Okay, here's
Oh
gender,
yeah.
and you can
Yeah.
see the count for males and females, and count for and so on and so forth. There's a couple of nice things here. One is you don't waste any papers. You can experiment with this all you like. You could sit here all day and just make every imaginable bar chart. So this gives us an idea what the rate is for receiving a flu shot if you're male versus if you're female. Bigger different, like yeah, bigger percentage if you're female received it than if you're male. And you can do a lot of this. The other thing you do is you can double click into this and it actually opens an editing window where you can go in here and play around with these various. You could, if you wanted, you could change the color of the chart. You can change the depth and the angle, so you can make it 3D. You can. I don't. My advice to you is don't play around with that. I'm sorry I brought that up.
Okay.
That's always a bad thing. Let's see if I can. There's a way to get in here, change the colors if you want. Oh, the colors are over here. Hang on a second here. Yeah, I think you can go in here and change the colors here. Well, make a long story short. It's been a while since I've played with this, but you can go in here and change. You can go in and click in and change the labels and so on and so forth,
Oh, there's the color palette. Oh,
and
great.
change the colors. Do a lot of stuff you want. But I would just experiment with it for a while. Play with it, like make believe that you just bought a new bicycle and you're taking it out for a ride. Okay.
Except
Unfortunately, you can't do it outdoors in the sun on a sunny Saturday like we have today. You're stuck indoors playing with this, but you can play around with it. So we have other variables here: insured, insure five. You can go to the code book and find out what insure five means, what the question was, and then you can go into the variable view for insure five, and you can give it a more descriptive variable uh, type of health insurance coverage. Now, that's not too bad. I would eliminate the five categories. You don't need to say that because it's going to be obvious. But you go into the values group and you can tell it what those five categories mean. So now your tables that you produce, your graphs that you produce, are going to have some meaning. Okay, does that make sense to you?
it's cleared up so much for me. Thank you. Yeah, I really appreciate the walkthrough.
No problem. So now what I would suggest you do is take a look at it, play with it, and we'll figure, like as the week goes on, give me a couple of emails. Tell me how if you want to email me some stuff,
Yeah, I would love to because
email me
I
some
also,
stuff. You could also upload it for peer review if you're not shy,
oh
but
yeah, I definitely will. Yeah, because I was just not, I could sense I wasn't on the right track
and
before.
now you'll also be able to get a look at what other people are doing as well, because they're uploading their materials as well. The other thing I wanted to bring up, let me just see where I put this thing now. Where did I put this? Let's see.
Oh, and so did you record this meeting?
Yeah,
Could
yeah.
I?
I'll put this up on YouTube before the end of the
Oh,
day.
cool. All right. Yeah, because I was thinking it'd probably also be helpful for whoever else might
Sure,
be.
absolutely. Hang on just one second here. Let me see if I can't find my. Oh, here it is. Okay. The other thing I wanted to bring. Oh yeah, there's. If you go on Blackboard, there's also sample projects.
Yeah, I was
So,
looking at those, and one of them, the one I looked at, it just looked so simple.
oh, actually, yeah. In fact, some of the best ones are simple. right?
Okay.
Now you're right. This person did really that. This person worked with a numerical variable, age
Yeah,
distribution.
that's one I was
So
looking
you were able to find means and so on and so forth. In this one, health insurance status, with just clustered graphs. And I don't think that this is the way it came out of SPSS. I think they did a little bit of modification with some sort of graphics here themselves. In other words, they cut them and paste them together.
at. Hmm.
Okay, and like this one's not very complicated, right? Took a look at
No,
looking at
so simple.
factors
That's why it's
affecting. Well,
memorable.
they did kind of a survey of a number of factors that affected the flu vaccine, but age was one of them. They also looked at health insurance status, whether they had it or not. But you could actually break that up into more stuff if you
Hmm.
wanted to. And they did some statistics. What kind of statistics did they do? Well, they did do some categorical statistics, flu vaccine by health insurance, right? Yes or no, and yes or no, right? And one of the ways that they did the way they were able to do that, which I didn't show you here, is you can transform these variables. Like that health insurance
Hmm.
was five different categories, right? And probably I would think that that would mean that they had private insurance, they had Medicare, they had Medicaid, they had some other kind of insurance, and so on and so forth. And they transformed that. So instead of having one means this kind, two means this kind, three means this kind, and five means none, right? What they did was they said one. If it's one in this, I'm going to make a new variable, transform, create a new variable. If it's one in the original variable, make it one in the new variable. If it's two in the old variable, make it one in the new variable. If it's three, make it one. If it's four, make it one. But if you have no insurance, make that two. So now you have a new variable that only has ones and twos, insured or
Oh,
uninsured. And then you can work with it and create and do a two by two table and calculate odds ratio, relative risk, and so on and so forth. So you can do a lot with this once you start to play around with it. I would start with the basics,
yeah.
see how far you get with that, and then we'll take another look at it. Okay,
Okay.
let's take a look at this one.
Thank you so much.
Okay.
Yeah.
And a lot of these they remembered that these were the I think the best five over a couple of years. And
Hmm.
as you said, look at this one. There's not that much here, is there? I mean, she did some very nice. Who did this one? Oh, Andrew. Okay, he did some very nice. First of all, number one, he did a good summary of what he's trying to show. Right? He told us, what his strategy was, what he was trying to demonstrate. Okay, at the time, that New York, in 2013, there was a lot of controversy over sugary drinks, so he picked that particular category out. And you're not limited to the 8 or 9 categories in the simplified group. You can go through the larger data set and see if there's any other variables in there you might be interested in. And he did descriptive statistics. He just did a bar graph, broke this up into the age groups. I think that's literally from the raw data. Okay, and let's see, race and ethnicity. Again, he did a simple bar graph. And you literally could have done that now with what we have available. Notice that the variable names and the groups and so on and so forth are simplified compared to what the original data. So he went in there and modified the descriptions a bit.
Okay.
Okay, he
Yeah,
talked about his methods, right? And
yeah.
I guess BMI. I don't know if he calculated BMI or if it was in there already. I guess it's probably in there already, right? Yeah, let's see. Summary and conclusions. Yeah. So quantity is not the most important thing here. It's like putting some thought into, what do I want to show, and what can I do with the data? How can I manipulate the data or display the data so it's understandable?
Hmm.
Okie doke.
Yeah, thank you so much, Tony. This is a good way to start Saturday and get into it.
Okay. Okay. Good. I'm glad to hear that. I'm not so sure I agree with you, but there are probably better ways to
Please
start it. But
don't.
this is a